I wanted to work on a disease, particularly one affecting young people and children. So that's what led me to MS. So we know that there are two components, the brain and the immune system. They're the two most complex biological systems that we know of. And when the two of them clash, well, obviously you're going to get a very, very complex disease. Collaborations with investigators working in other fields is really critical. At the Baker Institute, they are looking at different types of inflammatory diseases. They're looking at thrombosis, atherosclerosis. MS as an autoimmune is also an inflammatory process. This is where there's a meeting of the minds. In my lab, we focus on the blood-brain barrier, which is the interface between the blood circulation, where you would find the immune cells swimming around, and the brain itself. The more we talk, the more we realize that the principles involved in building up the sort of spectrum of immune cells that will cause the disease remains the same. Whether we're talking about sepsis or atherosclerosis or rheumatoid arthritis or MS, there are commonalities. They are using techniques which are totally new to me. A lot of imaging techniques, tracers, radioactive tracers, to look at the concentration of the accumulation of particular cell types in different regions of the brain. And it's not something I've been doing. They are very much an experimental tool rather than a diagnostic tool. So, but they want to take it from the experimental to the diagnostic. And to do that, they need my model. So that's where we meet. So I want their techniques and they want my model. Further studies of the role of platelets using imaging techniques combined with pathological techniques hopefully will consolidate the hypothesis that these cells actually play a role which has never been described before. We think that actually this particular cell type can find a way to get in to the brain as well. And that's never been shown before. Obviously, the next thing is to find out how to stop them from getting in. And perhaps by 10 years, we could have new targets for drugs on the blood-brain barrier. The funding is immensely helpful because it allows us to take our time to develop the methodology or explore the model so that we can really address very, very direct, very precise questions to the model. The second thing is that it gives training to young people. The scholarships allow the students to obviously come in the labs and learn from us and develop skills and learning to think scientifically.